given a relation, how do we represent it? Okay, how do we represent it as to the computer, or when we want to show it, we want to give a diagram of that relation? There are two ways of representing relations, especially again, we are talking about binary relations. So imagine that we are talking about a binary relation from set A to set B, and the set A has m elements, A1 to AM, and set B has n elements, B1 to Bn. One way to describe the relation is through a matrix. For example, matrix M, where in the row I and column J, we put 1 there if AI and BJ is in the relation, and we put 0 if AI, BJ are not in the relation. So let's think about, for example, as an example, let's take A being the set of A, B, C, and B to be the set 1, 2, 3, 4, and the relation to be, let's say, A, 1, B, 4, and C, 3, let's say. So how do we represent this relation? Actually, let me add some element here, a couple of more elements, let's say C4 and A2. How do we represent this relation using this matrix? So I can build a matrix since A has 3 elements. The matrix has to have 3 rows corresponding to A, B, C. B has 4 elements. I build the matrix with 4 columns corresponding to 1, 2, 3, 4. Okay, so the matrix will have 3 rows and will have 1, 2, 3, 4 columns. So this row is A, B, C. This is 1, 2, 3, 4. And since A1 is there, this entry is 1. B4 is there, this entry is 1. C3 is there, this entry is 1. C4 is there, this entry is 1. A2 is there, this entry is 1. Everything else has to be 0. Okay, so we fill these with zeros. So this is the matrix that represents this relation. Okay. Another way to represent a relation is through a graph. So a directed graph here. So we introduce one node per element in the set, and we put an edge from node A to node B if AB is in the relation. So for example, this graph I'm showing here, if I want to reverse it to say what is the relation, the first thing I notice that there are 4 nodes, one labeled A, B, C, and D. So every black circle there is one of the elements there. So really the set we are defining the relation over is A, B, C, D. And what is the relation itself? The relation is over A times A. What are the elements in the relation? So now I can look at them one by one. Okay, let me use a different color here. So for example, I have an edge from A to D. So this means that AD is in the relation. I have an edge from A to B. This means that AB is in the relation. I have an edge from B to B. It means that BB is in the relation, B to B. I have an edge from C to B. This means CB is in the relation. I have an edge from C to A. This means C to A is in the relation. I have an edge from B to D. This means BD is in the relation. And I have an edge from D to B. This means DB is in the relation. And basically, this is the relation that we described using that graph. So I can go from this relation to this description, or from this description to this relation. Okay. So if you look first at your set, the elements that it has, you introduce one node for each one of these elements. And then we add an edge from node that's labeled by A to a node that's labeled by B if AB, the pair AB, is in the relation. And we do not add an edge from AB to A to B if the pair AB is not in the relation.